All right, so we are looking at solving a quadratic. So we're finding our roots, we are finding our solutions, we're finding our zeros. So the first example says find the zeros for the quadratic function, and we have y equals 8x squared plus 50x minus 42. So the first thing, like normal, is we want to make sure it's in standard form. So we're going to do the work on one side and do some meaningful notes on the other. So we're going to start with step 1. And so let's do this. Let's just say we want to make sure it's in standard form first. Which it is. And so we can move on to like a real first step. So we're going to say the first step is to factor out a GCF, which is the same as before. So we always start with trying to find our greatest common factor. So we can go ahead and do that. So over here, we're going to have step 1. And if we look at our numbers, we have 8, 50, and 42. The GCF between those numbers would be 2. And so we can divide everything by 2. So we want to divide this by 2, divide this by 2, and divide this by 2. They don't have a variable in common, so we're left with y equals, our GCF goes in front, and I'm going to change the color here. So what we're left with is 4x squared plus 25x, because over here we have 50x divided by 2, and then we have minus, and that's going to be minus 21. So that's our first step. Now, something I noticed is that our a value is not 1 anymore. So we have a 4 for our a value. So we have to do something different when we're factoring. Okay, so our step 2 is we want to make a t-chart still, but this time our t-chart is going to look a little different. So we're going to say make our t-chart because we want to factor still. This time we want to find numbers, but first we have to multiply our a and our c together. So this is a little different. So we want to make a t-chart of numbers that multiply to whatever a times c is and add up to b. Okay, so not just multiplies to c, we actually want to multiply a times c first. So our a value is 4, our b value is 25, and our c value is a negative 21. So if we multiply a times c, that would be 4 times negative 21, which is negative 84. So for our t-chart, we want numbers that multiply to a negative 84 that add up to 25. So before we just did numbers that multiplied to c when our a value was 1, which we technically did a times c, but if a is 1, it's just c. So the negative 84, I'm going to change the color here. Let's do this. So this came from multiplying the 4 and the negative 21. Okay, so we're going to do a times c. So we can go ahead and make our t-chart. So negative 84, because we're multiplying to a negative number, one has to be positive, one has to be negative. So we have negative 1, positive 84, or positive 1, negative 84. We have negative 2, 42, positive 2, negative 42. We have negative 3 and 28, or positive 3, negative 28, but that's actually the pair that I want, that right there. So I'm going to stop. I don't have to keep going. I could keep going if I want to, negative 6, positive 14, positive 6, negative 14, and then, 7 and 12, but I'm going to stop right here because I already found it. Okay, so we found our pair that works. Now here is where it goes different. So I'm going to scroll. Okay, so for step 3, we're going to do something called the reverse box method. Okay, so for step 3, we're going to do a box, but this time we are filling in our squares first instead of the outside. So for step 3, we're going to say fill in boxes with our 4 terms. So there's 2 that we know automatically. So our first term in our equation was 4x squared. So if we actually looked up here, we're going to plug in 4x squared and the negative 21. So our x squared term and our constant. So we have 4x squared and our negative 21. Okay, so that came from our equation that was inside our parentheses. Okay, so that came from right here. So, oops, sorry. So right here and right here. Those 2 are going to go in the box down here. Okay, so we have 4x squared and negative 21. The other 2 boxes is actually coming from these 2 right here. Okay, so negative 3 and a positive 28. Those combined make up the 25x, that middle term in our equation. So we're going to do a negative 3x and a positive 28x. That's why we have to make our t-chart, so we know those 2 factors. Okay, we put an x with both of those because when we combine those, we get 25x, which was part of the original equation, that middle term. Okay, so now we have our 4 boxes filled in. Okay, step 4, I'm going to do in green because it's a little different. So for step 4, what we want to do is we want to factor out our GCF from every row and every column. Okay, so what we're going to do is, let's look at the first column. We have 4x squared and 28x. The GCF between 4 and 28 is 4. And between x squared and x is x. Okay, so that's our GCF of these 2 terms. Then we can do the other column. We have negative 3x and a negative 21. The GCF between 3 and 21 is 3. They don't have a variable in common, so we can't pull out a variable from those. Now, because this is negative, our GCF has to be negative. Okay, so we can say, like, if the neighbor is negative, so if the box it's next to is negative, then our GCF is going to be negative. So like our 4 was positive because its neighbor here was positive. Okay, so now we can do our rows. So our first row is this one right here. So 4x squared and negative 3x. The GCF between 4 and 3 is just 1. And then between x squared and x is x. So we can pull out 1x. It is going to be positive because its neighbor is positive. Then we look at our second row. We have 28x and negative 21. The GCF between that is a positive 7 because our 28 is positive. Its neighbor is positive, and they don't share a variable. Okay, so I'm going to write over here step 4 is in green, which kind of goes with step 3. Okay. So for step 5, I'm going to switch back to the same color. So for step 5, we can go ahead and write it in factored form. So we have our factors. So we have 0 equals, because we do want to set our factors equal to 0 eventually, like before. We have our GCF still, which was 2. And then we have our 2 parentheses. 1 parenthesis is our 4x minus 3, which comes from up here. And our second parenthesis is x plus 7, which comes from over here. Okay, so those are our two parentheses. So for our step, we're going to say, write it in factored form and make sure it's equal to 0. Okay, so we have it in factored form. Now, this step is going to be the same as when we solved before using factoring. So we can go ahead and I'm going to change colors so we can break these apart. So any part with a variable, and we set them equal to 0. So we have 4x minus 3 equals 0 and x plus 7 equals 0. So this is our last step. This is step 6. So we're going to say set our parentheses equal to 0 to solve for our roots. Okay, so this is just like before. So to solve this, we want to add 3 to both sides. So we're left with 4x equals 3. Then we want to divide both sides by 4, and we get x equals 3/4. Or if you want to write it as a decimal, it'd be 0.75. That would be fine. And then this one, we want to subtract 7 from both sides, and we get x equals -7. So we found our roots. We found our zeros. We found our x-intercepts. So we have 3/4 and -7.